cyclotron, a deuteron, which is equal to 2 times the mass of a proton, which is about 3.35 times 10 to the negative 27 kilograms. I'm going to be saying that that's 2u. It's going to reach 10% the speed of light being 3 times 10 to the 8 meters per second. It's going to be moving in a circular path with the radius being 0.48 meters. The magnitude, the question is, what is the magnitude of the magnetic force is required to keep the deuteron in a circular path? To set this problem up, I had to draw a picture here. And I wrote down the force of magnetic is equal to ma, the mass being 2 times the mass of a proton. And my acceleration, well, this acceleration, I had to turn that into something relating it to the centripetal force, because that's what's going to keep it in a circular path. To do that, you have to write it down as v squared divided by the radius of the circle. Then after that, you plug in all your values. So the force of the magnetic force is equal to 2 times the mass of a proton, 2u, times the velocity squared. The velocity of the deuteron is a tenth of the speed of light. And it's going to be divided by over the radius of the circle. Solving for these values by replacing 2u with 3.35 times 10 to the negative 27 times 1/10, 3 times 10 to the 8th, squared divided by the radius should give us 6.27 times 10 to the negative 12 newtons of force. That's the force required to keep the deuteron in the circular path.
Nice. That was perfect time too. All right. What else? I'm sorry. I'm trying to use it as a
Was it a stop?
Yeah. There's actually a pretty big error on this problem because it's traveling at 1/10 the speed of light.
So just click stop. Like just click this and take it out, right?
Yeah.
That means that